Hey everyone, good day. So welcome back to another Prism Caribbean video. And today we'll be going into number theory. This topic in particular isn't tested to its vast extent within the past papers. However, knowing it will be quite essential in solving other questions and problems, such as sets in particular, right? So now jumping onto this topic, we'll just go over some basics, which I will call the prerequisites. Let's just call it prereq for now, right? So we need to know some things about natural numbers, right? We need to know about the whole numbers. We also need to know about integers. Also rational numbers. We also need to know about irrational numbers, right? We also need to know about real numbers, prime numbers, also composite numbers, and that should be it. If there's anything else, I will just add it on. So just go into a recap with all this. Natural numbers, so these are like basically counting numbers, right? Also known as counting numbers, right? Like 1, 2, 3, etc. On the other hand, whole numbers whole numbers include counting numbers and 0, right? So integers now are basically positive and negative numbers, including 0, right? We also have to know about rational numbers, right? So rational numbers are numbers that can be written in the form of a fraction, and it can also include positive and negative fractions. So positive, negative, numerator over denominator. So basically what this is saying is fraction, right? So it can be positive or negative fraction, as well as including the number 0. Noting what includes 0 and what does not include 0 is quite important, right? So regards to irrational numbers, these are numbers which, you guessed it, cannot be written as a fraction, right? So these are like square rooted numbers, like square root of 3, or the square root of -7, or even pi, right? So yeah. So we also have to know about real numbers, right? So real numbers include rational and irrational numbers. Right? And there is another form of number which you don't really have to get into at this level, called the imaginary numbers, right? Which is denoted by the symbol I, right? But of course you don't have to worry about that right now. With regards to the prime numbers, these are numbers which can be divided by itself, and 1 alone, right? Right. So now we also have composite numbers. So composite numbers are numbers which has factors, which has other factors besides itself and 1, right? So yeah. Right. So the factors of 16 will be like 16 by itself, 8, 4, 2, and 1. Since we know the factors of 16 are not 16 and 1 alone, we know it is 8, 4, and 2, we can say it is a composite number, right? And this is just the basics. Of course, there are other types of numbers like square numbers, rectangular numbers, and more of that sort. But getting on to the basics, we have these, and then you can go into all of that, right? There's also one more thing I'd like to show you with regards to the number theory topic, which is actually tested in the past papers, and is quite important, of course, right? In the past papers, sometimes they like to test particular laws, like, for example, commutative laws, and maybe even distributive laws are also tested, and even for grammatical errors. Let me just move this on here so I can show it as many more, and even associative law. For the time being, we will go through these two for today in this video, right? For the commutative law, right, this deals with the order in which operation is performed. Right? And the two operations which follow the commutative law are the addition and multiplication operations. Now I'm going to show you why. Let's start off with the multiplication. Let's say we have, something to multiply like 4 by 3 by 17. Now, the order in which we multiply this by really doesn't change. Let's say we decide to multiply it in a different order. And let's say we decide to start with 3 first, then maybe start with 17, then maybe start with 4. When we multiply these out, we will still get the same number of 204. Let me just double check that. Yeah, 204. So as we can see, the order in which the operation is performed does not matter, right? It does not matter. So the multiplication follows the commutative law. Now with regards to addition, let's say we have something simple, 2 plus 8 plus 9. Now, again, the order in which we add these numbers does not matter. We don't necessarily have to start with 2, then 8, then 9. Let's say we start again with 9, and let's say we go backwards, 9 plus 8 plus 2. We will still get the same answer as 19. And you can see the addition and multiplication follows the commutative law, right? Now, if you do this for division and subtraction, you'll realize it will not follow the commutative law. So, for example, division. Let's say we are dividing 9 divided by 3. You'll get 3, right? But let's say we do it the opposite way and say 3 over 9. You'll get 1/3. We know this does not follow the commutative law. As well as subtraction, right? We can follow it, just like that. Let's say we have 99 minus 88, right? Of course, we will get 11. But let's say we have 88 minus 99. Again, that won't work. We will get negative 11, and it's not the same answer. So the subtraction will not work as well. So again, with the commutative law, it deals with the order in which the operation is performed, right? Which basically says, hey, if I do this operation or this question in any different way, whether it be multiplication, a different order, or addition, a different order, we're still getting the same answer. So the order does not matter in this case. However, for division and subtraction, as you can see, the order does matter, right? So moving on now to, let's move on to the associative law now. Right? So now with regards to the associative law, this law really deals with the grouping of numbers. Right? Now I'm going to get into this now. Again, with regards to the associative law, I will show you why, again, addition and multiplication works. So let's start off with addition this time. Right? So if we have 4 plus 9 plus 13, for example, we know if we group this in any other way, such as, let's say, 13 plus 4, we add those two first, then we add the 9, we will realize that we will be getting back the same answer of 26. Right? Even if we say, alright, let me not do that first. Let me say 9 plus 13 first, and then I will add the 4. Again, we will get back the 26. Simple enough, right? Let's move on to multiplication. Let's say we are multiplying numbers like 19 by 2 by, let's say, 3. Again, with multiplication in the associative law, it does not matter what you multiply, which 2 you multiply first, and then you multiply the last number. Let's say we multiply 2 by 3 first, and then we multiply by 19. Of course, 2 by 3 is 6 by 19 will give us the same answer of 104. 114. Let's say we decided to do it a different way. Let's say we decided to go, 19 by 3 multiply by 2. Of course, plugging that into a calculator, we will be able to get back the same answer of 114. Hence, we know the associative law holds true for both addition and multiplication. But this will not hold true for subtraction or even division as seen before. Right? There's one more topic I would like to go through with regards to the number theory. Right? And I will go through it in another video.